Hello everyone. In this video, we will discuss question number 9th of my end semester paper. So the first part of question number 9 is ANN architecture overview. So the structure of an ANN, an artificial neural network, is a composed of layers of interconnected nodes designed to mimic the human brain's structure. So data flow directionally from the input layer through hidden layers to the output layer. So feed forward process information moves only forward connections. Each connection an associated weight and each neuron has a bias. Activation function determine if a neuron should be fired activate based on the weighted sum of inputs. So the image of artificial neural network architecture showing input hidden and output layers. So the role of each layer, so the input role of input layer is functions receives raw data from the external environment. Data entry. Each neuron corresponds to an input feature, example pixel value, age, income. No computation. Neuron here do not perform complex computations. They simply pass the feature values forward. Size determined by the number of features in the dataset. So hidden layer function perform the bulk of the computation and featured extraction. So feature learning transform input features into meaningful intermediate representation. Complexity. Multiple hidden layers deep learning allow the network to learn increasingly complex pattern. Activation applies an activation function example ReLU sigmoid to introduce non-linearity. So the output layer generates the final result on the network processing. Prediction provides the predicted output predicted size determined by the task one neuron for binary classification and neurons for class classification. Activation uses an appropriate activation example softmax for classification, linear for regression. So B part of question number 9 is backpropagation algorithm. So goal is effectively update the network's weight and bias to minimize the difference between the network's output and the target output. So the cost function, the chain rule of calculus. Backpropagation uses the chain rule to calculate the gradient of the cost function with respect to every weight and bias in the network. So the gradient partial derivative example is derivation c divided by derivation w is equal to dc upon by dm dot df divided by dz dot dz divided by dw. This allows the error to be distributed backward layer by layer starting from the output. So the backpropagation algorithm steps. So the training loop, step 1, forward pass. Input data is fed through the network to generate an output prediction. So step 2, calculate loss. The difference between the prediction and the true level is calculated using the cost function. Step 3, backward pass. The gradient of the loss is calculated backwards from the output layers to the input layer. So step 4, parameter update. So weight are adjusted using gradient descents and suitable examples are task binary classifications. So first is forward input image network predicts. Second is loss true level is low. Loss is high because 0.9 is far from 0. Backward the large error signal is propagated backward weighted contribution most to the incorrect 0.9 prediction are identified. Update weights are adjusted to decrease and increase P for the next iteration. So the process repeats thousands of times and the B weighted update using gradient descent. So back propagation provides the direction gradient descent executes the update. So gradient descent formula. The core concept is to move the weight in the opposition direction of the gradient scaled by the learning rate. So theta nu is equals to theta old minus alpha dz theta upon d theta. So cost minimization by following the negative slope we designed towards the minimum slope. Learning rate control the step size. Top too small means slow training, too large means unstable training. So here is the graph. Thank you for watching this video.